All right, here's our title for today. We are doing properties of irrational exponents. They are pretty much the same as the properties of exponents we started chapter 6 with. So if you remember all those special rules about exponents, that'll come in handy today. Today is 7-2. And our goal is to use properties of rational exponents to evaluate and simplify expressions. Now, I told you guys, just looking forward to this week, we have 2 days on this section. Now, I am pretty sure I can present all this material in one class period, which gives you basically tomorrow in class to do the homework and I'll answer questions. So if we can keep it moving at a decent pace today, tomorrow will just be kind of like a work day and we'll do several problems if you need them on the board. Okay? Questions? If you took notes at the beginning of chapter 6, you should have these already in your notebooks. These are the exact same ones we looked at. And I'm going back to kind of the easy examples just to remind you what the properties are. So here, they both have the same base. Oops, that's not the arrow I wanted. They both have the same base, so you just add the exponents. Whether the exponents are fractions or whole numbers or whatever, it's that same property. You just add the exponents. And then there's a pretty simple example for you. Here's another one, the power of a power property. So any exponent to another exponent, you just multiply the exponents. Again, here is just looking at an example with easy numbers. They'll get a little harder today. We'll introduce some fractions and things. Here's another one, power of a product property. So A times B all to the M is A to the M and B to the M. Again, here's a simple example for you. Today we'll get into more difficult examples. Whoops. All right, here's another property we learned. It's the quotient of powers property. So notice that they have the same base, and we're dividing them. You can just subtract the exponents. Again, here's a simple example. We will kind of kick it up a notch for today's lesson. But it is important to look back at kind of the easier examples before we make it challenging. Here's the power of a quotient. Another one we've looked at previously. So if you are dividing inside parentheses with an exponent on the outside, you can just take each piece, the numerator and the denominator, to that power. Other important things to look at, remember anything to the 0 power equals 1. And an important thing to look at for reciprocals, so anything with a negative exponent, it's actually just the reciprocal. So if you have a to the negative n, that's the same thing as 1 over a to the positive n. All right, here's our first example. So remember, you should know how to do these. We've just never looked at them when we have fractions and the exponents. So if there weren't any fractions, if it was just like x to the first times x squared, you would just add the exponents, right? Same thing here. Now you're just adding with fractions. So 1 plus 1/2. Thank you. This is going to be x to the 3/2. Reduce in what manner? No, keep them top heavy. Or yeah, improper fractions. We leave them this way in case it wants us to write them as using radicals. So the 2 would become the index and then the 3 stays with the x. Yeah, if you change them to a mixed number, it'll get kind of fuzzy there. So leave them improper. Here's another example. So remember, negative exponents, just take the reciprocal. So y to the negative 2/3 was in the top of our fraction, even though you can't really see a fraction. So you just move it to the denominator. Put a 1 in the top as a placeholder and make the exponent positive. This is a power to a power. What do we do? Multiply. Good. So you do 2/3 times 6 in your exponent. 2/3 times 6 gives you 4. 4 to the 4th. Now you all have calculators, so you can type in 4 to the 4th if you'd like, or just look on the board. It's 256.
Subtract.
Yeah, you just subtract the exponents here. It's y to the 1/3. Any ideas what to do on this one? Yeah, we change it to 64 to the 1/3. Do you guys know what 64 to the 1/3 is? It's like the cube root of 64. It's 4. Square root would be 8, but yeah, cube root is 4. Now, you could either change it to the cubed root and use that little like X root button on your calculator, or you could do 64, the caret button, and then 1ABC3. Either way, it should give you 4. Questions on those two? All right, same base. What do I do with the exponents? Add them. Good. Now, I'm assuming you all do calculators on this. We don't really have to discuss the whole common denominators thing. Unless somebody really wants to. Here's how you would do common denominators. But again, I'm assuming you're all doing calculators. Don't leave it 1 1/6. There is a button on your calculator that will make it improper for you. I believe the button looks like this. That'll take it from a mixed number to an improper fraction. I heard, how do you do that? How do you do that? We just added the exponents, so you can do it in your calculator or you can get common denominators. But you should get 1 1/6, but I don't want it written like that. I want an improper fraction, so you do 7/6. Questions? So anytime you have two radicals with the same index and they're multiplying, you can multiply the radicands. So this would be the cubed root of 64. Now, if you think back to your rational exponents rules, this kind of makes sense because you could write them as both to the third. And then it said two things multiplied together. If they're each to the third, you could put them in parentheses together, all to the third, multiply first. So all these rules kind of work together. But what is the cubed root of 64? 4, we already talked about it. Good. What would you do here?
Square root of 36.
Yeah, you just multiply the 6's together, it'd be the square root of 36, which is obviously 6. Great. Now remember, we will talk about something called rationalizing the denominator. It's where you get all the square roots out of the denominator, or cubed roots, or fourth roots. Kind of remember this trick. Square root of 6 times square root of 6 is 6. That'll help us out in the future. All right, now you guys have probably noticed, just going through math classes, that usually something that's true for multiplication also works for division. Same thing here. They have the same index. So you can go ahead and just divide the radicands. So this is the fourth root of 16. What is the fourth root of 16? 2, good. That's when, again, if you wanted to put the plus or minus, that would be appropriate in this case. You can go ahead and divide the radicands here because they have the same index. It would be the cubed root of 125, which is 5.
Would all of these have plus or minus?
No, that one you could not use a plus or minus on.
Oh, yeah, because it's odd.
Right, because it's odd. Yep, so 7 and 10 you could not. Honestly, like I said, 8 and 9, I probably wouldn't even use the plus or minus. If you wanted to. It is, from the examples we looked at, the pattern would hold that those get the plus or minuses. Typically, you see the plus or minuses either on like really simple ones, where I just give you the square root of 36, or especially when you're solving equations. When you're solving equations, they're not optional at all. But here, usually when there's multiple steps, people kind of lose the plus or minus. So I won't be super picky on these, but yeah, you can put them with 8 and 9. The book will probably have them with 8 and 9. Questions? All right, so now we're going to look at just some different ones. So whenever you found the prime factorization of 32, meaning you broke it down into factors, we had 2, 2, 2, 2, and 2. You have 5 2s. They come out in groups of 3. So the group of 3 came out front to give you a 2, and then you're left with the cubed root. Make sure you don't lose that index. A lot of people just automatically do just a radical, a square root, but you had 2 2s left over, so you need the 4 inside and then the index of 3. Questions on that one?
Wait, why did you put it into 3? Why did you circle the 3?
This is where they come out of the radical in groups of 3 because the index is 3.
Okay.
So like when we were doing square root problems, you guys were really good at these. You'd circle them in groups of 2 to bring them out. Here we need a group of 3 to bring them out. If it was a 4, you'd need a group of 4 to bring them out in front of the radical. So that's why I circled it in groups of 3. All right. Here's number 12. All right, so number 12 on the board, I told you guys I was going to show you the steps first, then I was going to explain it. So here are just the first couple steps. This is a process called rationalizing the denominator. So whenever you started here, you had the fourth root of 2 over the fourth root of 9 if you broke this up. Can you take the fourth root of 2? Not exactly, right? If you did this is prime, so there's no number that multiplies to give you 2. So nothing's going to work there. You can't break it down. The 9 can only be broken into 3 and 3. You need 4 of them to simplify, so there's nothing you can do there. What you want to do is turn the bottom into something that we know the 4th root of. A very easy 4th root to find is 81. So we can multiply the top and the bottom by the 4th root of 9. That's going to turn our denominator into the 4th root of 81. Now, what is the 4th root of 81? 3. That was the whole point. Now, if you did a factor tree for 18, it would not simplify, so we'd be done. Now, we'll look at more where we rationalize the denominator. This is the first one we looked at. But remember, you want to eliminate radicals in your denominator. We looked at these when we were doing square roots. It's not totally simplified if you have a radical in the denominator. So just think of, is there something to the 4th power that you can turn the bottom into your denominator so that you don't have any radicals in the bottom. Now, a lot of people would have done 9 to the 3rd. So then you'd have 9 to the 4th and then take the 4th root. That would work. Here you just have a much bigger number at the top. So this is just kind of the easy way, kind of a shortcut one to look at. But we will look at lots of these over the next couple days. Any questions at the moment? So again, back to our PowerPoint. After looking at the prime factorization of 256, we know that that's 4. I'm going to have 2 groups of the x's. So that gives me an x squared in the front, 2 groups of 4. And then inside the 4th root, I have a y. Now, like I said, off to the side, I wrote out all the x's. There will be times where you won't want to write out all the x's. The shortcut is to divide the exponent by the index. Because you're looking for, well, how many groups of 4 are in 8? That's a very simple division problem, okay? So if you don't want to write them all out and circle them in groups, just do simple division. Questions on 13? All right, here's 14. Excuse my coughing. Any ideas looking at 14? Yeah, for the numbers you get 2 over 3, right? I'm just going to write those off to the side because on there the whole answer pops up. I don't want to ruin it for you. So I know 2 and 3 will come out of the square root. The x will come out. The z will come out. What's the only thing left inside the square root? Y. So there's your 2, there's your x, there's your square root y, there's your 3, and there's your z. Nope, so I was just going to say that some people like to keep the whole thing as one fraction, so you'd put the square root of y in the top, just like it is. If you wrote it this way, that's the exact same thing, so you would be fine either way there. If you wanted to write 2x over 3z times square root of y, same thing. Questions? All right, we're going to look at adding and subtracting with radicals next. You need to think of these kind of as like terms. So the 5th root of 3 and the 5th root of 3, that's kind of like saying x and x, okay? If they have the same radical with the same index, with the same radicand, we're good. You can just combine them. So it's kind of like 2 minus 1. So it would be the 5th root of 3. Mm-hmm.
Where did the 2 go?
You want
It's kind of like saying 2x minus x,
Oh, 2x plus
but we're just calling x 5 fifth root of 3. I mean, they're not x's, but like I said, it's kind of like terms. You can only add them if they're the same. So on the next one, you can see inside the parentheses, it's both 2 to the 1/8. So you could actually just add those and make it 11 times 2 to the 1/8. So it seems like overly simple, but it is important to look at. Same thing here. I heard somebody whisper it. You just add the 4 and the 2. Square root of x plus square root of x. Just add the numbers in the front. Which obviously gives you 6. Square root x. Now, like I was saying, this is a very easy skill. This should not be mind-blowing, but it is important to look at just so you're aware of how to handle these. Any questions? Here's your homework. You can see it's a lot, and there are some things that we only kind of brushed on the idea, like rationalizing the exponent, simplifying using the prime factorization, stuff like that. When you get to those problems, we can do them together. You can try them on your own, but we do have the rest of class today and tomorrow to kind of get everyone on the same page on these. So just let me know if there's ones you want to see on the board. But you have kind of seen all the basic skills. Now you just got to put them all together. Questions?